Okay. Now, listen carefully. Now, Puta, you know, now you are starting your A levels. Just now you are starting your A levels. And recently, set of A level results came for 2024 A level batch. So the last A level batch was 2024 A level batch. And their results came last Sunday. Okay. So there was lots of amazing stories in it. Okay. So many stunning stories and amazing stories, right? So you have to know those and you have to inspire. Okay, you have to get inspired by those stories. First thing, there was, however, you know, every year, however, island first, those things will come. Those students, there are students. Mostly island first, mostly get island first from first shy students or second shy students. First shy students. Mostly island first, first shy students. Okay. Mostly island first, first shy students. Easily, we don't get second or third shy students as island first. Mostly island first is first shy. Island first, second, third. All comes to normally first shy students. Rarely it will come, but mostly 99% first shy students. And there was a student who was who did the O levels during 2024. 2024 May, they had the O level on May for 2023 batch. 2023 batch students, they had their O level 2024 May. 2025, the 2024 batch, no? You had 2025 March. So these people had May. This is the O level day. 2024 December, they had advanced level. 2024 December, right? December name is January. 2024 January. January, set of people got holidays, no? That's because of this. 2024 January, I'm sorry, yeah. January only, they had this A level. Then 25 January. Then January A level, March only O level. Just like that, no? January government school students got holiday, no? Can you remember? Right? Okay. Anyhow, so this child did O level. It means direct senior. You are direct senior. Just 1 year older than you. So she completed her A levels also in math stream. And she got 3 A's with an island rank 100 and something. Okay. 3 A's with island rank 100 and something. What did she do? What she did? While studying O level, because O level is very easy. O level is not actually a big thing. It's one of the most easiest exam in Sri Lanka. Right? Although you think it's difficult, after 2 years, just turn and see your O level, then you will feel that. Then while doing O level, she did her A level studies as well. And she got 9 A's in O level. And also, she got 3 A's in A level. Now, she has selected for engineering faculty, right? So just 1 year older than you. So people are doing like that. And there was another child, okay, I guess not from here, from not from Colombo. This is from Colombo. Another person was from, I guess, here, some central something, right? Supposed to do A level in 2025. It means just 1 year senior than you. Sorry, 2 years senior. You're 27 O level batch. No? 2020 is supposed to do 2025 A level batch. It means the A level which is gonna happen currently. It's gonna happen currently. I mean this year November as an A level. So supposed to write A level this year, but wrote 1 year early. Wrote last year. Okay, 2024. wrote the exams. Then what happened? Wrote 1 year early and island sixth. Okay, in biological science. So people are doing like that. Okay. So one thing. So why they can get like this? Why they can get 3 years short time period, a syllabus which is very deep and which you have to study 2.5 years? Because normally from your O level year mean A level year will be 3 years. After years only you get the A level year. O level if you're writing at your 2024 batch, O level 2024 batch mean your 2027 A level batch, right? So you have almost 2.5 years to study. Okay, 2.5 years to 3 years. Okay, between a time period between that. So a such big syllabus, a person is finishing early with a high ranks mean definitely that student is intelligent. One thing. Second thing, what can you tell about the syllabus? It means it's a syllabus where you can get good marks. Just study properly. This is a thing. There is nothing called what difficult. Everything. What's the main thing? Everything your hard. So just see this child how she saved the time period. Otherwise, she should have written the O level 2026, not this year, also next year. But wrote this year with island rank 100 and something from Visaga College. Go Madek. So, first thing, Puta. So, if you are doing your A levels, your prime target should be A level. You should not get engaged in other stuffs. All right. So, we will guide to go for maximum results, but you have to do the work. You have to keep on working. Right. Today, I will teach you a timetable called 24/3 timetable. Right. Now itself, you have to start working with it. Your motivation should be, however, I should do a work and should get a massive, not just ordinary results. You should get a massive results. Okay, we will support you. Okay, we'll support you for that. What happened? Right? We will support you for that. Okay, 100% will support you, but we need your side work also. Right? Think. First of all, you understand this A level means not a big thing. If it like very deep, these people can't score like this. Wait, obviously they can't do that. So what does it mean? Yeah, it's deep, but still it's a thing which you can handle. Right? So keep that in your mind and work with her. Definitely, you can go for a very, very good results. Okay, so keep that in your mind. Right. With that will work, right? With mindset will work, definitely will go for a great place. Okay. Because I have a work plan where you can get plenty of marks. And first thing, the laziness should not be there. And I'm happy, Puta, about you. Like even the students who came last week, they also have completed the entire note. Means now you have the NEET. Because this is a very big competition Q water. If you get 3 years, you can go for medical faculty or engineering faculty, HRI, right? Nothing other than that. You get 3 years, I got you right, because you can save plenty amount in your hand and also you're a university student. The only thing is say, after you are entering to university, however you can get through from those exams. Those are not difficult than A level. Level is one of the longest syllabus. Like entire 2.5 years you have to do at once. But university, when you go to university, it's not like that. It's like STO annual system. Semester mean every 6 months you will have an exam with whatever you have learned in that 6 months. And all mean every year you will have an exam, whatever you have learned in that year. එච්චරයි. එතනින් ඔය කතාව ඉවරයි. ඒක ඇතුළට ගියොත් කොහොමද පාස්. ඒක කියන්නේ හිතන්නේම normally වැඩ කරලත් you can pass. දැන් මෙතන තමයි you have to marry ගැන වැඩ කරනවා කියන්නේ. You have to die and do the work. So I will give a schedule 24/3 කියන schedule එක. ගොඩාක්ම one of the powerful schedule. Mostly powerful people use this. හරිද? ඒ powerful people use කරන ඒ schedule එක උඹලට දෙන්න යන්නේ අද. හරිද? ඒක හරියට use කරන්න ඕනේ. දැන් කියන්නේ නැහැ ඒක. පස්සේ කියන්නේ. 24/3 schedule. You haven't heard that. අහලම නැහැ. Because it's my schedule. Okay. Right? That's why I said people use. Right? හරි. Now, හරි. Now finally we spoke about a thing. Okay, last week actually we did a very short session. And I told you last week, I told you about Crookes experiment. And the scientist William Crookes, he got the tube, he got the what tube? What tube? Test tube. The Crookes tube. He used the Crookes tube. And which gas he inserted here? He used hydrogen gas. This is the Crookes tube, he used hydrogen gas. Big amount or little bit amount? Little bit hydrogen gas. Okay. And I told you, if you want to function this Crookes tube, there are three things. There are three conditions. What are the three conditions to function this Crookes tube? Number one, high voltage. You should have a high voltage. Approximately how much? 10,000 volt. Second, yeah, you should have low pressure. You should have low pressure. Okay. And you should have a medium. There should be a gas. There should be a gas. Then normally we are using hydrogen gas. You can use any gas, right? But normally we are using hydrogen gas because it is less weight. And when you use this with high voltage and low pressure, and you applied something on this tube, what did you apply here? What did you apply? You applied, last week I told, zinc sulfide. When you apply zinc sulfide, what did you observe? Yes, you observed when the some green color glitters, some green glitters. That's illuminating with green color. Lights, green color. Okay. Then he observed that. First, he didn't know what it was. He observed these radiations coming from, I told this is positive side, this is negative side, mean this is positive, this is negative. For positive side, we call it, what we call for the positive side? Anode. What we call for the negative side? Cathode. Negative side is as cathode. And he observed these radiations. These radiations comes from where? From this negative. He observed this radiation comes from negative side. So he named these as what rays? Cathode rays. Okay. Because he found cathode rays first, this tube has another name, CRT here. What is CRT? Cathode ray tube. Okay. Now, what type of particles are coming from this key? We'll speak later. Now you should know what is this cathode ray. And now we are going to speak. Last week I told about this. Now today we are going to speak about the properties of this cathode rays. Till you don't know what type of ray it is. Now we'll see what did scientists do to identify these rays characters. We'll see one by one. Right. Now you know only one thing from his experiment. This has this glittering and some rays coming from this. Some radiations are coming. HRI, you know up to now. Now the next question I have asked, what are the properties of cathode rays? What are the properties of cathode rays? Now we are doing the student who didn't get the tube online. Although you didn't get, now you just want to remember. Now there is a tube like this. Okay. They did an experiment and they saw some radiation, right? You should know now. And this radiation is coming from the cathode side. Therefore, they name this as cathode rays. Now we are going to speak about the properties of these rays, right? Once you get the book, you can fill the notes. What is the question number, Puta? Question number 10. Question number 10 only, properties of cathode rays, is it? Okay. Now we are going to speak about question number 10. I'll start the tute with you, right? But at the moment, now, first of all, we'll speak the properties. Okay. Now, first of all, we should see what is this? Is it an energy? Nothing. Is it some particles? First of all, we have to see that. First thing, this is not energy. This is not energy. These particles. Okay, these particles. How they said these are particles? Because now when energy is passing through, will something happen? Again, will you feel that? And some energies you can feel. But what did they do? In front of the cathode ray tube, this is a cathode ray tube. Cathode ray tube. Cathode, anode. Make an anode and cathode. Right? And what did they do? They kept a metal cross in front of this. They kept a metal cross in front of this. Then what happened? What happened? They kept this. Now radiations are coming like this. Radiation coming like this. Okay. These are radiations, invisible radiation. Then they saw, okay, what did they see? A shadow, a large shadow of this cross. Okay, behind the screen, they saw a large shadow of this. Large shadow of this. They saw a shadow like this. Okay, why I'm showing green color? Because it glitters in green. That's why. Okay. So they saw a large shadow like this. And thought, why they are getting a shadow? Because of the particles. And they thought, and they said, these cathode rays, this is the first point I'm going to tell, these cathode rays travel in a straight line. That's the thing they found by this. Because they are traveling straight line, that's why they are making a shadow here. This is the shadow. Okay, shadow. This is the shadow. Very easy, Puta. Don't take much deep things. Think how you're trying to wire out more or you put the words. Yeah, man, right? Normal things. This is the local part. I make a shadow. Only when you in the cathode ray tube, if you keep across, you will get a shadow. It's right. Why? What's the reason? What's the reason? Cathode rays traveling straight line. Cathode ray straight line. That's the reason. Second, now they don't know what type of radiation is this. Then what they did, then the next experiment. From this, what they found, we'll write that also. What they found here, Buddha? They found cathode ray. My handwriting are beautiful. Travel. Can see, no? Beautiful, no? Travel in a straight, what the? Straight line. Although you can't, is it difficult to read? Can read, no? Can read, no? Because everyone tells my handwriting are beautiful. My teachers, right? So even the doctors who are there, they can understand nicely. Can understand. Okay. Then next one. Uh, the same cathode ray tube. Okay. This size is not enough. How only. Good. Cathode ray. This is anode. This is cathode. Putana everything they have connected to current. Nikang when they give the radiations on come. They have connected these to current. No, I'm not drawing the other parts. I'm drawing only the tube. Don't misunderstand. In the tube, it gives some radiation. No, no, no. You have to put gas. Now, Puta, and when they keep two charges, they are keeping two plates, a positive charge plate, they're giving current for this direction, a positive charge plate and a negative charge plate. And they so, again, now I said cathode rays are invisible radiation. How they see this? Because of that zinc sulfide application. Because of zinc sulfide, when it goes and what goes and knocks to those metals, what happen? It will cause fluorescence. Fluorescence can some glitters. Yeah? Color it will glitter in green color. With the glitter only they found what's happening here. And they so now just I'm drawing the radiation. You can't see the radiation. You can see only the glitters. So I'm drawing this because of the don't think only nicely we can see these are going like right? This remember now they so these radiation without going straight, they start to travel for this direction. And what's the assumption you can make from this? Now they are turning towards this. You all intelligent people. What's the assumption you can make from this? You don't tell. You know. Anit cut. 2027 batch people tell what's the assumption you can make? Cathode rays are negatively charged particles. Because cathode ray is negative, that's why it's going for a positive. Normally negative things are attracted to positive things. Positive things are attracted to negative. That's life. What did they see? Actually, the experiment they saw some what fluorescence. Fluorescence. They saw fluorescence here. Another name, fluorescence. They saw fluorescence. From that, what they decide? What did they decide? Another property of cathode ray revealed. How do we? Okay. Cathode rays are what? Negatively charged. It means it's a negative charged. Okay. It's a negatively charged particle. Then they got current. And third thing. All right. Now cathode rays are negatively charged equal to Q. Now you know it's a negatively charged particle. Either again, this is anode and the cathode kept a paddle wheel. What does it be? Paddle wheel, right? And normally when they give me a paddle wheel, side view, if I draw, there is something to hold the paddle wheel. And around this only, this paddle wheel is placed. How is that? When they kept the paddle wheel, what happened? On this paddle wheel, start to rotate and also it start to go forward. So what they decided from this cathode ray, cathode ray has a momentum. Cathode ray has a momentum. You know what is momentum? When you in grade 10, you have learned in physics, E equals mv, momentum. Momentum means it has some energy. Okay? I mean, it possesses energy. It's not an energy, it possesses energy. Okay? So these things, they identified. These are only some of their characters. Okay? Some experimental characters I showed you. But first of all, we'll write one by one. Now, have I given these pictures? Have I given these pictures? Have I given these pictures? Have I given any of these pictures? Yes, yes. Right. Okay. Now now come to page number this one. So in page number 3, I have given a parallel wheel. Page number 4, I have given the picture how they are going to positive side. And in page number which one? Oh, I have given the shadow also. All things I have given. Are the online student I will share it. ලැබුණා කියලා කිව්වනේ. First of all, we'll write. Okay, first write point by no need to draw this. ඔක්කොම draw කරලා තියෙන්නේ උතන. Nothing to draw newly. Then අපි කරගෙන යමු. Right, number 1. Properties of cathode ray. No need to write cathode ray again. Right, it travel in a straight line. It travel in a straight line. Okay. Second, number 2. What the number 2? Number 2. It turns to the positive charge plate. It turns to the positively charged plate. It turns to the positively charged plate. Okay. Next one. It has a momentum. It has a momentum. So from with those 3 diagrams, you should understand those. So under those diagram also you write those things. Okay. For the respective diagrams, below that diagram, you write those points. So there is a first diagram na puta. Yeah, first diagram. AK. You can see right. The first diagram, under that you can write. What is the first diagram? What should you write? It has a momentum. Under that you write those things. Likewise, respectively write things. Online student, I will share this. So this is the tube puta. So in this, there are so many scientists. Now I'm talking about these 3 diagrams. Okay, you can zoom this. So now just I told only about only 3 properties, right? Right. Now everyone wrote these three things. Then next thing happened. Now I said they used hydrogen gas, no Buddha. I said they used hydrogen gas. Now already I explained you there is a thing called what? EM ratio. I explained you there is a thing called what ratio? EM ratio. So under EM ratio, right? Under EM ratio, EM ratio means what's the meaning of EM ratio? EM ratio means normally electrons charge, E means charge divided by mass. This has a ratio. It is known as what? EM ratio, right? So remember this EM ratio, what they did an experiment by putting various gases. I said now hydrogen, then they put helium, they put nitrogen, they put oxygen. They tried with different gases, but what happened? EM ratio didn't change. EM ratio didn't change with the gases. It has a constant EM ratio. Okay, so that's the fourth point. But they try with different gases and they check this EM ratio. Okay, they check charge divided by mass ratio, but it didn't change. Right. Then write the next point like this. EM ratio, EM ratio, next point. No, no. Now still we are speaking about the properties of cathode rays. Beautifully write. So please write using a pen. Okay. EM ratio did not change with the gas. Okay. Next one. So I said, now cathode rays, now I said, no, it's a particle here. And also it has wave properties also. Cathode ray can act as particles and waves, right? So write the next point. Cathode ray, no need for cathode ray. It shows particles and wave-like properties. It shows particles and wave-like properties. It shows particles and wave-like properties. It shows particle and wave-like properties. And the next point. Look at the next point. Next point is now when you give a magnetic field, also it deflects. Okay, it deflects even in a magnetic field. Write the next point. It deflects in magnetic field. It deflects in magnetic field. It deflects in magnetic field. Okay. Will it deflect in electric field? What do you mean by deflect? What's the meaning of deflection? It turns like this. That is only deflection. It's something coming like this, and if it turns like this, known as deflection. Okay. So does it have deflection in electric field? Yes or no? Answer Bhutanika. What do? Does it has deflection? Even online students, you all can answer. Does it has deflection in magnetic field or electric field? Yes or no? Yes, no? That's deflection. No? What the way cut here, it turned this way. No? It has a deflection. A deflection already we said it turned to positive plate. Now you are like errors. No? Magnetic field only we wrote deflection. Electric field we didn't write deflection. So it is wrong. Okay. So properly when you're studying, or don't study like O-level people. Don't study with that O-level mindset. When you're learning something, or properly or what are these words? Like properly learn this. Only you can go for high results. Okay, that's very important. Okay. Other thing is We are going to speak about the speed of this, right? Normally, cathode rays speed is put up like it is actually close to, it is close to speed of light. We don't say it is exactly speed of light. It is not going in speed of light. It is close to speed of light. Okay, it's close to speed of light. So if there is a statement, cathode ray travel in speed of light. It's false. Write the point. It travels close to, it travels close to speed of light. Right. Next thing. Now, with the cathode ray is traveling in front of the cathode ray's path, if you keep a thin metal foil, till this cathode rays will pass this metal foil, right? Can go through this thin metal foil, very thin, like a paper, foil, right? So can pass through the foil, right? Right. The next point. It can pass through a thin metal foil. It can pass through a thin metal foil. It can pass through a thin metal foil. Okay. These things okay? Okay. Next point. So nice, beautifully write. Take space and write it beautifully. Now you have enough space. Next page also we have given space, right? These are custom note. Now next thing, when cathode ray is traveling to the, we'll say there are gases. Again, now we'll say now you have filled hydrogen gas here. Now hydrogen gas. Is hydrogen. Gas is inside this. Now this is what the heat, not hot. 10,000 volt එකට දානකොට heat කියන්නේ superior heat, army heat. Sattawadi heat, superior heat. Now what will happen? This hydrogen. So hydrogen is what? Is it an element? Is H2 an element? H2 කියන්නේ element එකක්ද? Is it an element? Question, right? H2. Question is number 1, element. Option 2, molecule. Option 3, compound. Option 4, 1 and 2 both. Option 5, all 3. Which option you will select for this hydrogen? Online students also can see me. You also please put the answers in the chat box. Everyone should tell an answer. Arun? So you have to just show your answers. You have to just raise your hand when I'm asking. Online kattiya, please put your answers. Please send your answers in the chat box. Chat එක tag ගාලා දාන්න පුතා answers ටික. tag ගාලා දාන්න. Online students, please send in the chat box. Very important. Most of the people මේ basic එක දන්නේ නැතුවම ගොඩක් කට්ටිය ඉන්නේ. හරි. tag ගාලා online people tag ගාලා send your answers. ඉක්මනට. මේ Google search කරලා යවන්න හරිද? කියන්න එන. You can tell. For telling number 1. For telling 1. 1 කියලා කියන්නේ කවුද? 1. 1 එකට කවුරුත් නැහැ. 2. 2 එකට answer 2. Good. 3. 3. four, four. What? Two. Which one is the correct answer? The correct answer is this. Okay, one and two both. If something is made out of same type of element, mean you're thinking only H is element. If same type of things are joined together, those are known as element. If more than one element join, we are calling them as molecule also, right? But what is compound? Compound mean two different elements should mix together. Two different. Molecule mean more than one. If anything more than one, they are molecule. CO2 mean, is it a compound? CO is a compound. More than one element. Is CO2 is a molecule? Yes, CO2 is a molecule as well. If it more than one element connect mean it's a molecule. It might be same type of element. It might be different type of element. Okay, molecule and compound. Understand this. Does O2, just H2 is a compound? H2 is a molecule. Compound when a different type of element should mix together. Those are must. හරිද ඒක ඔක්කොම sure short. ඒ කියන්නේ definite things. හරිද oxygen means O is element. O2 is an element. O3 also an what the element. ඔක්කොම elements තමයි. Oxygen element can present in three ways. O, O2, O. Big ඔක්කොම elements. This is a basic knowledge. මේ ටික ඔයාලා දාගන්න ඕනේ. Right? You have to put somewhere මෙන්න මේ ටික ඔයගලගේ writing book එකේ හරි writing book එකක් තියෙනවනේ. මේ writing book එකේ දාගන්න. Put H2 and write this MCQ and you write the explanation also. හරිද? first ටික දාගන්න. Very important thing. හරියටම you should know. හරි. Compound means two different type of element should connect together. Okay, that is only compound. Right. Now these things are okay. Till I didn't tell the other part. Exactly. Right. Now, these things are gonna. Okay. Now, Putra, they used what gas now here? Hydrogen gas, right? Now they used hydrogen gas. Putra, what happened to this gas? Now this subject you write the meaning also, and he just don't write element mean right. What is element? You know there are the basic classification of chemistry. PO substance. Here like PO only. There are two things: elements and result. Elements and compound. It's right. PO substance. So compound also PO. Elements also PO. Right? Always in. So under compounds, only you learn about the other things, right? Always here. And other thing is mixture. And mixture. Mixture mean what? More than one thing in it. It's a carbon dioxide and nitrogen together. Right. Did you all understand this? Is it clear? You get the proper idea. So you can write oxygen, O2, ozone, all are elements. And also O2 and ozone are molecule as well. Okay. They are not compound. Now what happened? I said no, because of heat, what will happen? This hydrogen molecule, okay, this hydrogen molecule, this will break because of heat. There's a for hydrogen atoms. Will break into hydrogen atoms. So hydrogen, I mean, how many hydrogen atoms are there? Two hydrogen atoms are there. Two hydrogen atoms are there. Correct? No? Good. Then hydrogen will break into two hydrogen atoms. Next thing, okay, first will happen like second. What will happen when cathode ray knocks this? When cathode ray comes and when it comes and knock to these gases, okay, when it meet the gases, this hydrogen will this hydrogen will lose electron. Hydrogen will lose electron. Normally, hydrogen has how many electron, Putha? What a hard question, no? Kya hango bang? How many electrons hydrogen has? Line students, you also should reply. How many electrons? One electron. So it will lose its electron. Now, when this cathode rays comes, it will lose that electron. When it lose the electron, this hydrogen become what, Putha? H become H plus. H plus mean what's the meaning? It has lost its electron. When they lost its electron, it become plus ion. So in H plus, how many electrons are there? In H plus ion, how many electrons are there? Zero electron. No electrons in it. So when they make a positive charge, now what happens? This happened because of whom? Cathode ray. Because of cathode ray only this happened. Okay. This happened because of the heat. So because of cathode ray, gases can lose electron. This process is known as ionizing. What? Ionizing. So we are saying cathode ray can ionize gases. Okay. So this process is known as what? Ionizing. Ionizing කියලා we are calling. එතකොට we are calling මොකද්ද cathode ray can ionize gas. The next point you should write cathode ray. You understand the process now? Is it clear what I'm telling? Then write the next point. Cathode ray can ionize gases. Cathode ray can ionize gases. කියලා ලියලා write these two things with ලස්සනට ලියා ගන්න ඕනේ. Right. Now next one. Okay. Okay. Now for the write another point like this. It produce fluorescence. Right. It produce fluorescence. Right. Now next one. Now these things are okay. Okay, fine. Then you can write the body tika තමයි තියෙන්නේ. You can write it cause heating effect. It cause heating effect because of cathode ray it has heating. Then Puta, if I ask like this, okay, next thing. Actually, මොකද්ද මේ cathode ray කියලා කියන්නේ? What is this? මේ මොකද්ද මේ? The negatively charged particle කියලා තියෙනවා. ඕගොල්ලෝ දන්න negatively charged particle කවුද? Who is the negatively charged particle? Whom you know? Who is it? An electron. So, actually, what is this cathode ray? It's a beam of electron. What is cathode ray actually? It's a beam of electron. ඒක ඔළුවේ තියාගන්න. Now, you can write that cathode ray is a beam of electron. Okay. ඒක ලියාගෙනම තියාගන්න. Cathode ray is a beam of electron. Right. Now, we studied now so many points. ඒක ලස්සනට දැන් එකපාරක් go through කරන්න. I will give 2 minutes. ටක් ගාලා study that now. මේ ඉගෙන ගත්ත cathode rays properties ටක් ගාලා you go through. Right. Now enough. Uta, I will give a quick exam today. Whatever the things you have done so far. So again, whatever we will learn up to now, I will give an exam. Without books, you should write this alone. We'll see how many marks you will get for this. Study today I will give quick exam series cannot like now get ready for an exam. Whatever we have done so far, you will have the exam. Now don't think about exam, come to the lesson. Right? You come to the lesson. Exam make a winner lesson talk away. Right? Now, online students, you also will have the exam. Right, good. Even both the online students, please reply. Reply again in the. Now, come to the next question. Next question is, what the how is EM ratio found by? Who found the EM ratio? EM ratio found by Thomson. Very good. EM ratio found by Thomson. So what you should fill in that blank? EM ratio found by Thomson. J. Thomson. J. Thomson. EM ratio found by J. Thomson. That is okay? Right. J. Thomson only found the EM ratio. Right. That's okay. Now, how he found this? So I have given the diagram. I'll share it. I have given the diagram. You can see here, Buddha. Okay. What he has used, can you see he has used? What he has used? Can you see there is a hole? The hole is in what? Can you see there is a hole? Where can you see the hole? In the cathode or anode? See the diagram? See the diagram and tell me where you can see the hole. The cathode or anode? Zoom kar lo. Can you see? Which one has a hole now? Cathode or anode? Oh, both. Both name. Carefully see. Anode, very good. So what he did, he used an anode. He used an anode with a hole. And also, can you see? And he sent that through what? What field? Can you see? There is a magnetic field. Can you see? Magnetic and electric field both. Can you see both fields are there? He's sending, he's directing. There is a cathode here. The anode with a hole. And when he send this through this, what the wind, and he will send this between a magnetic field and also electric field. Okay. Using this only, he found this EM ratio. So what you should know for your syllabus, how he performed this. And you should know J. Thomson only found the EM ratio. And he performed this by sending these rays through, and he used the anode with a hole. He used the anode with a hole, and he sent these through electric and magnetic field, and he found EM ratio. No need anything. So he found the EM ratio. And you should know the value of EM ratio. You should know this value. Or the EM ratio's value. How much is it? EM ratio's value. Right? You can see the picture here. EM ratio's value, Puta. I'll take this. 1.76 into 10 to the power 8 grams. Grams mean grams per coulomb. Sorry, coulombs per gram. Okay, coulombs per gram. Okay, 10 to the power 8. By charge is measured by coulomb, mass is measured by gram. So we can write Cg minus 1. Correct. If you write this in coulombs per kilogram mean, what should I write here? Taggala think. Don't tell the answer, Taggala think. After 1 minute then now, you have to think an answer. Coulombs per kilogram means, what should you write here? Don't discuss. You all think. And everyone write an answer for that. Nikang use a pencil and write an answer in your no need here. Koi liya no. Otherwise you all just think and wait. Don't discuss. ඔයාලන්ට දෙන 1 minute එකේ පොඩි දෙයක් තමයි කිව්වේ කරන්න. Don't discuss. Right. Now, very hard. But show your answers. ළමයි කොහොමද හොයාගත්තේ කියලා. Write a proper answer. මොකක්ද මේ? Write the final answer. I don't like that. Eh? Eh? Answer. මොකද? So how you got? Okay, all wrong. Again, from this we can say, you don't know the basic, right? Okay, from this we can say you don't know the basic. Okay, you don't know online students. Did you send an answer? Online students, Taggala show me your answer. Taggala Tell your answer. No one gave the answer. You have to convert this coulombs per gram. How should you convert to coulombs per kilogram? That's a big deal. That's not a big deal. How you got this 1.76 10 to the power 8? Remember, these are important everywhere. Physics, chemistry, everywhere. Coulombs per gram mean coulomb up and down. That is only a coulombs per gram mean. You know that, right? You all know that. Coulombs per gram mean coulomb divide by gram only. We write coulombs per gram. Okay. M is minus 1 kilo, what you write? M divide by S, no, you write M is minus 1. Likewise, coulombs divide by gram only, coulombs per gram. Now I want to convert gram to what? This gram only now I want to convert to, speak. Gram only I want to convert to kilogram. Now I want to convert this to kilogram. How to convert gram to kilogram? Multiply or divide? I'm gonna tell it. Multiply or divide? Gram to kilogram. Divide. Divide, no? Divide by how much? Divide by 1000. Correct? No? Divide by 1000. Then, if I want to divide this by 1000, 1.76 into 10 to the power 8. Okay. Down, I should write divide by 1000. Divide by 1000. The down part now divide by 1000. Hey, man. 1000 should come down. Divide by 1000 should come for the gram part now. So divide by 1000. If you write, how will it come? 1.76 into 10 to the power divide by 1000. You can like this number. Actually, what you are writing 1.76 into 10 to the power 8 divide by 1 over 1000. I am taking this one out. Divide by 1 over 1000. You know, understand what I'm telling? Make a down. Ek divide by 1000 ki divide by 1 over 1000. There is no number in numerator, so I have put 1. Then what will happen? Division will change to? What will happen? Division will change to multiplication. And 1000 will go up. 1000 mean what? 10 to the power 3. So 1.76 into 10 to the power 11 coulombs per kilogram. These unit conversions must. Okay. So here 1.76 into 10 to the power 11 coulombs per kilogram. Is it 100% clear? You understand? Do you understand the conversion part? Well, your conversion you should be able to do. Okay, say coulombs to gram, you can write like this. And gram you would convert to kilogram, and you have divide the down part by 1000. If you divide the down part by 1000, you can know any up part no in this. I would divide by 1 over 1000 kilo. I can. But normally we don't do division. We have tried as multiplication. 1000 will go up, 1 will come down. We set around 10 to the power 11 kilo. Clear? So you should be very intelligent, very sharp. Just you are coming after O levels, but still you should adapt to these conditions. Understood? Clear? Right. Then now we'll write about this experiment first. First write like this. J.J. Thomson used a cathode tube with an anode which had a hole in the middle. And he sent it through a magnetic and electric field. Through a magnetic and electric field. And he found the EM ratio of cathode ray. EM ratio of cathode ray. Right. So write this EM ratio. Write the conversion also. Okay. All right. Is it okay, Naputa? Now there is a chart. Okay, there is a chart. Now it means you should know how to do questions with these. Okay, with these things. It means you should know this value. Eh? You can't forget this value. This value, EM ratio value, is very important. EM ratio value you can't forget. EM ratio is one of the important value. And I have given so many other values as well. I have given you a chart now. And online students, the people who have the book, okay. Just now see, I have given you a chart here. In that chart, I have given how many columns? 4 columns. First column, I have given particle. Second, I have given a thing called relative charge. What have I given? Relative charge. Relative charge. Then the next one, real charge. There is a thing called real charge. And the other one, charge of 1 mole. Charge of 1. And the other thing is inventor. Inventor name actually who discovered. Discovered by. Okay. Inventor name actually it's supposed to be discovered by. Now, particle first one is electron. Electron I can symbolize E. Electron, proton, and neutron. I can just use these symbols. Not standard. These are not standard. Normally, what is the relative charge of proton? Which one is neutral? Who is neutral? Neutron. So, relative charge we are taking 0. When you take to neutron, proton is positive charge. So, +1 we are. Relative to neutron, electron is -1 charge. So, this is only what are we calling? What charge? Relative charge. And real charge of the electron is 1.602 into 10 to the power -19 coulomb. Again, you should understand how small it is. 10 to the power -19. What does it mean? 10 to the power -19 mean? There are how many zeros? After the decimal point, there are 18 zeros. After the decimal point, there are 18 zeros and then only 102. How small is that number? So that's very small charge possessed in one electron. So this is electron charge, we are writing minus scalar. For proton's charge, we are writing 1.602. It also has the same charge, but it is a positive charge. And this has no charge. What do you mean by charge of 1 mole? Charge of 1 mole means what is the charge in 1 mole? 1 mole mean what does it mean by 1 mole? 1 mole mean how many atoms are in 1 mole? How many atoms are in 1 mole? I ask you a question. Number of atoms in 1 mole, yes? Very good, excellent. Tell the full word. Excellent. The number of moles, the number of atoms in a mole is equal to Avogadro. Okay. It means Avogadro means a unit. Okay. Avogadro unit means if you take 1 mole, for example, just imagine, you know, Sau. You know, Sau candle. Have you seen the, it mean we are calling Sagu kiela, Sagu. Have you seen? Have you seen that white color thing? From Sagu only you make, but Sau candle. How Warisi? Have you seen Sau Warisi? That white color thing, have you seen? I didn't ask, have you taken Sau Warisi? You know Sau Warisi? How can you know? Tasting? No? They make payasam, everything, right? Very nice. So, Buddha, in that Sau candle, have you seen this? There's a small seeds again. In Sau candle make karne ke, or poti, etta wage dakala thiyena, white color. So can you tell how many? Take rice. Okay, rice. You know, rice is made out of what? Rice. It's a seed. No? Seed right? එතකොට ඒකේ seed එකේ we'll say අර seed yeah we'll say 1 kilo, how many seeds are there කියලා කෙනෙක් ask. How many in 1 kilo of rice, how many seeds are there? කාටද කියන්නකෝ. කියන්න බෑනේ. ඒ වගේ තමයි අර 1 mole කියන්නේ නිකන් අර කිලෝ එකේ rice එක වගේ. How many atoms are there? I mean, like rice seeds. Okay. එතකොට ඒ කොච්චරක් තියෙනවද? Mean that is amount is equal to Avogadro. The number of atoms means something rice seeds. 1 mole කියන්නේ like 1 kilo. 1 kilo bag එකේ කොච්චරක් තියෙනවද? So it is 1 mole mean a number of Avogadro are there. 6.022. 1 Avogadro කියන්නේ it is equal to 6.022 into 10 to the power 23. You can measure a number of atoms are there in 1 mole. Okay, that is very important. It's a very big amount. 6022 and another 20 zeros. Just imagine the number size. If our salary is like Avogadro, right? Should we come for classes? Should you go for classes? Just imagine you have a deposit in your bank, Avogadro amount. Should you go for classes? උඹලට මේ මැරණකම් ඇතිවම මේක. Right? But it didn't happen like that. So we have come classes. උඹලත් coming. Right? එහෙමනේ. Just imagine if you have money in your bank account, will you come to learn? You mean, man, you will invest this in some business, or you will use some of this amount and you will buy some apartment. අරගෙන ඕක නිකන් rent එකට දුන්නා. ආතල් එකේ උඹලා යනවා foreign. ආතල් නේ බං. Should you learn? උඹ පොඩ්ඩක් numbers ටික learn කරගන්න to add and subtract. ඉතින් ඔය ටිකක් දන්නවා නම් ආතල් එකේ life එක settle නේ. එමුන්නේ නැහැ. So Avogadro is very important. හරිද? ඒක money තිබ්බනම් සුපිරි ඉතින්. හරි බලන්න. $15 even සුපිරි. Right? හරි. Uang itu right? Okay. Anyhow, so understand there's a Avogadro number of atoms in 1 mole. එතන මොකද්ද කරන්නේ? So one electron is this mean 1 mole of electron. How to get that? 1.6022 you will multiply by 10 to the power minus 19 you will multiply by this. So you will get the number of charge of 1 mole. ඒක simplify කරාම පුතා ඉන්නේ ගහුවා නම් 96,500 coulombs per mole. يعني මේවා no need to by heart. මේ එතන 96,500 ඔය ටික ඉතරම by heart කරන්න ඕනේ ඒවා නෙමෙයි. Normally two things you should remember. One thing, charge of electron එක පොඩ්ඩක් remember, not a big thing. 1.602 the power into 10 to the minus 19 and charge of 1 mole එක පොඩ්ඩක් remember. මෙන්න ඒකත් ඕනේ නැහැ. මෙන්න මේ charge එකයි EM ratio එක. ඒ පොඩ්ඩක් ඔය දෙක පොඩ්ඩක් remember. And these are discovered by ඒකත් 0 and discovered by electron discovered by කියන්නකො පුතා. ජාජා ජේ කියන්න ජේ Thomson. එතකොට මේක proton discovered by මොකද කවුද? proton Goldstein. proton කියන්නේ positive charge එකනේ. It was discovered by Goldsmith නෙමෙයි. Goldsmith කියන කවුද? Goldsmith කියලා මොකද්ද වැඩක් තියෙනවනේ. Right? Goldstein. අනිත් එක කියන neutron discovered by Chadwick. මෙන්න මේ ඔළුවේ තියෙන්න ඕනේ. It's very important. ලස්සනට ඔය ටික පුරවන්න. Beautifully. හරිද? ලස්සනට ලියන්න beautifully. Write these things. Done? Okay. All done? Good. Now, what is the next question? We have another question. EM ratio, mass of an electron. Mass of an electron when compared to hydrogen atom. There is another set, right? Ekat, now we have to know what does it mean. හරිද? හරි. ඒ කියන්නේ we have to fill those things as well. Hari. Now normally EM ratio. How much is the EM ratio? These things also very important. Already we mentioned that, but now we'll take into a different table and we'll write. What is the EM ratio? How much? You all first speak. First don't write. First you speak. What is the EM ratio, Buddha? 1.76 into 10 to the power 8 coulombs per gram. Second thing, mass of an electron. Electron's mass. Again, ME. Electron's mass is how much? 9.1 into 10 to the power minus 28 grams. Okay, minus 28 grams or kilogram. 28 grams. Then mass of an electron when compared to hydrogen atom. Again, when compared to hydrogen atom, mass of an electron is 1 over 1831. So who is larger, hydrogen atom or electron? It means hydrogen atom is 1831 times larger than electron. That's why electrons mass when compared to hydrogen 1 over 1831. Put මේ values actually no need to මොකක්ද? By heart. No need to by heart. හරිද? Mass of a proton is how much? Right? 1.64. Mass of a proton 1.64 into, okay, mass of a proton MP 1.64 into 10 to the power minus 24 grams. Then next one, mass of a proton when compared to electron, that is 1840 times. Mass of a neutron is 1.6744 into 10 to the minus 24 grams. So here from these things, what you should understand, this is neutron's mass, Mn. You have Me, Mp, Mn. Out of this, whose weight is more? Ek vitarak, if you know, okay. Whose weight is more out of neutron, proton, electron? Who has the highest weight? Now see this center. See this value center. Now I have given mass of electron, mass of proton, mass of neutron. Whose weight is more? Whose weight? Electron's weight is more. Why? Because minus 28. Then the minus value increasing mean, what does it mean? This value increasing mean become even smaller. Okay, are you following what I'm telling? Can follow, no? Minus value increasing mean value is going even lesser. Whose weight is more now? Mass of both are here 10 to the minus 24, 10 to the minus 20. Go to 1.64, 1.67. Which one is big? 1.6? 1.64 is big. What the numbers done nothing? 1.64 big or 1.67 big? 1.67. Obvious. So mass of neutron is more than mass of whom? Electron. Okay. So mass of neutron, mass of proton, then only mass of electron. Okay. All right. Now write these things in that chart. මෙන්න මේ chart එකේ තමයි පුතා. I will share the chart for the online student. Java it's big කියලාද කියන්නේ? It's 10 to the power minus 28. 0.01 is big or 0.1 is big? So 0.05 is big, 0.1 is big. Which one big? 0.1 is big than 0.05. Just okay. කට්ටිය අර පොඩි කාලේ ඉපරපු මයින්ඩ් සෙට් එකේ තමයි ඉන්නේ. චුටි කාලේ. රයිට්. අර උඹලගේ ලොකු ප්‍රශ්න අහන්න ඕනේ නෑ බන්නේ. හරි. ඔයගල් රයිට්. රෝට්. උඹලට කිව්වා ලියන්න එපා කියලා. So fast. හරි. Whatever you have learned just keep on recalling. උඹලට sudden exam එකක් දැන් තියෙනවා. Whatever again these values won't come. එහෙම කාටර විදියට අහන්නේ. Values mean I said no some values are important. Nah. හරි. Now these things are okay නේද? හරි. හරි. පුතා this there is a thing called this one protons. I have put the discovered by කියලා. Okay. For that we wrote Goldstein no puta. There you write actually Goldstein only did the first experiment earlier, right? Goldstein only did the first experiment. There was a small this thing you have to change that. Goldstein did the experiment, but the credit goes to Rutherford. So, right? Cut Goldstein and write Rutherford. But Goldstein practical only help him to find that. Okay, so write Rutherford there. Okay, Rutherford. Okay, because Rutherford did an experiment called gold foil experiment. Using that only he found what? Proton. Okay, he discovered proton. Okay, right. Proton, positive charge. Actually, it happened with the nucleus. So under Rutherford, have you written that? Under Rutherford, found 3 types of emission. Okay, after that, interviewed the latest atomic model. Okay, ekatama you can write discovered proton. Ekatama you write under Rutherford When right, discovered protons using gold foil experiment. Okay, right. Come for the next thing. Okay, right. Now, properly study this part. Whatever I'm doing up to now will come your quick exam, right? The හරියට ඔළුවට දාගෙනම මේ ටික study කරගන්න. Whose one is this? Sir, is it yours? Right. They can go. Next one, see the next diagram. Now I'm going to speak about this experiment. Whose Goldstein's experiment. Now, see the next question. What was observed when a perforated cathode was used in cathode ray tube? That's the question. Okay. The question is, what was observed when a perforated cathode was used in cathode ray tube? So, perforated, what are they using? Perforated what? Perforated what? Cathode. Okay. Perforated cathode. Now, what is that perforated cathode? What the perforated cathode again? Right? What is perforated cathode? Perforated cathode means, now this is the tube, Nabuta. This one is the tube. In this tube, this is anode. This one, cathode. So perforated cathode means cathode decay, there are holes. Okay? There are holes. So this is only known as perforated cathode. We can like this. This is a cathode. Let me cathode decay. They are using holes. There are holes in the cathode. So what they observed from some red color. Who observed Goldstein only did this experiment, and he observed some red color, faintish glow here. He observed some red color, faintish glow. And later part, he did some other experiments, and he found this red color faintish glow actually caused the positive rays. How positive rays happened actually? Like this. Earlier I gave an equation, hydrogen will break into hydrogen atoms. Then this hydrogen atom will lose its electron and it causes the positive hydrogen ion. If you use hydrogen, this will happen like this. If you use nitrogen, nitrogen will break into atom and nitrogen will lose its electron and nitrogen will form the positive ion. Understood? It can happen to any gas. According to the gas, what you use. So what happened from this? These positive rays started to come closer to the anode, but it's not coming from the anode. It's coming from closer to the anode. And these are going through these holes. And it causing some what color glow? Some faintish red glows. Okay. Normally rays are going from cathode to anode. This is coming from anode side to cathode side and causing some red color faintish glow behind the cathode. And these rays are known as anode rays. And these are going through these holes. No? Ain is over the canal rays here. Anode rays, canal rays positive rays. Okay, so this is found by whom? Goldstein. Okay, so this is happening actually like now we'll write like this. Name clear it was over and after that. Right. Goldstein performed Goldstein performed the experiment. Goldstein performed the experiment and observed a red faintish glow behind the perforated cathode. Behind the perforated cathode. Here they have asked only what was observed when a perforated cathode was used in cathode ray tube. Okay. So enough. Then next one, how canal rays. Number 14, how canal rays. And I have given two more brackets. What are the two names for canal rays? Positive rays, other one, anode rays. So write those two words for those brackets. In the method, how canal rays in the method, right? Canal rays you can write. What are those two? Anode rays and positive rays. All right, now for that you can write like this. Write this. After that, I'll give a break. When the atoms of gases collided, with cathode rays, when the atoms of gases collides with the cathode ray, it ionizes the gas. And create positive ions. Right? Then you can write these two, these things. Okay, reactions. Write these reactions. Write these two reactions. Okay. After that, write like this. They are not produced either in cathode or anode. They are not produced either in cathode or anode. Next point. They form closer to the anode. They form closer to the anode. They form closer to the anode. Okay. Next point. The positive rays are attracted The positive rays are attracted to cathode and pass through the holes of the cathode. And pass through the holes of the cathode. Rays are attracted to the cathode and pass through the holes of the cathode. Therefore, it is known as canal rays. Therefore, it is known as canal rays. Pass through the holes of the cathode. Therefore, it is known as canal rays. All right. Okay. Now, Buddha will take a 10 minutes break. 40 break for prayers. 10 minutes. Pray karlemo. Right. Okay. Did we write about the experiment? No, no. Right. What are the, no, we wrote an experiment. How canal rays form we wrote no Buddha. What are the properties of canal rays? Okay, now we have to speak about the properties of this positive ray. Okay. So these characters also mostly equal to cathode rays, but there are a certain differentiation. What was the first point we talk about cathode rays? Travel in straight line. This also will travel in straight line. No problem. Second thing we talk, second thing, it will go to it, will get what charge? It will turn to positive plate. The canal rays should turn to negative plate. Okay. Third thing, it has a momentum. This also has a momentum. Next one, what did we speak? EM ratio won't change with the gases. But here you can see the positive ray, whatever the positive ray produce is different. When hydrogen gas is used, H plus produce. When nitrogen is used, N plus produce. එතකොට EM ratio will change or no? EM ratio will change. EM ratio of the canal rays can change. Why? Because mass are different, nitrogen's mass is different, hydrogen's mass is different. Can you understand? Don't try to buy heart to understand. The EM ratio of the canal rays can change according to the gas. But cathode rays didn't change the EM ratio with the gas. Okay, those things are okay. Saved. Okay, what's the next point we spoke about cathode rays? Sorry. Yeah, so this also has particles and wave-like properties. Then, so these things are some important things. So these also have deflection in electric and magnetic field. No, we have to write. And also this also can ionize gases, right? Rays also can ionize gases. Thing, Raggala will write. No, Raggala will write. First one, travel in a straight line. Travel in a straight line. It can move the paddle wheel. It can move the paddle wheel. It can move the paddle wheel. It can move the paddle wheel because it has a momentum, because it has a momentum, because it has a momentum. Deflects in electric and magnetic field. Deflects in electric and magnetic field. Deflects in electric and magnetic field. Turn to negative plate in an electric field. Turn to negative plate in an electric field. Next point. EM ratio of the anode rays. EM ratio of the anode rays changes with the gas. Changes with the gas. Changes with the gas in the cathode ray tube. Changes with the gas in the cathode ray tube. Changes with the gas in the cathode ray tube. Right. Next one. Can write. You can write like this. Velocity of anode rays. Velocity of anode rays is lesser than velocity of anode rays is lesser than cathode rays. Velocity of anode rays is lesser than cathode rays. Velocity of anode rays is lesser than cathode rays. So why? Because their mass is high. Okay. Therefore, it goes slowly than cathode rays. Okay. So this produces fluorescence. This also can produce fluorescence, right? Produces fluorescence. Next point. Produces fluorescence. Okay. Next point. It can travel through thin metal foil. And you can see ionized gases. Ionized gases. And right. Theoretical coma make even. I think you know about these things now properly. Harid? Right. Now we'll go for the next question. What is the next question, Puja? The next question. Now, 15, what are the properties of canal rays? Okay, 16, what are the difference between cathode rays and anode rays? Is it? What are the difference between? Have I given like that? Difference, no? Okay, now you only should write. What are the difference between cathode rays and anode rays? Anode rays, why I have given bracket, you can write another name, but rays. Tagala, you just put some, if you're scared to put the difference, just put a column, cathode rays, anode rays, and put the compare and contrast. Difference between cathode rays and anode rays. Now you have done cathode rays and anode rays. Now differentiate that to the. I'll share the screen. Next question. What are the difference between cathode rays and anode rays? What are the difference between cathode rays and anode? Right. Just write the difference. Just put only the difference. Okay, what are the difference? What are the difference you know for these things? What are the difference you know for these things? Okay, what you wrote. Okay, we'll speak about few difference now. Difference between anode rays and cathode rays. Number one, first difference you have to say cathode rays, anode rays here. First of all, you have separate two columns. Cathode rays side you should write negatively charged particle. Anode rays side positively charged particle. That's number one difference. Number two difference, cathode ray you have to say turn to positive side in an electric field. So canal rays you have to say turn to negative side, but in a in an electric field. Third thing you have to say cathode rays produced in cathode. Produced in cathode. Anode rays you should write produce closer to the anode. Produce closer to the anode. Then you can say for cathode rays, velocity is closer. Velocity is closer. Velocity is closer to. Velocity is closer to light. Then for anode rays, you should say velocity is less than cathode rays. Right? Are these things okay? Right. Then what else? Yes. For cathode rays, you have to say EM ratio do not change with the gas. For anode rays, you should write EM ratio will change with the gas. Right? EM ratio will change with the gas. These are the main differentiation of cathode rays and anode rays. Who wrote all of this? At least almost you wrote, no? Do you correct these things? Corrected, no? Cathode rays, anode rays different. Okay, no? You can complete that. And complete. Complete the missed parts. Now, how many points I told altogether? 5 points, no? So please write, mark those 5 points. Right. So that part is okay. Now, පුතා මොකද්ද මෙන්න මෙහෙම සීන් එකක් යනවා. Right. After what are the difference between cathode rays and anode rays? Next one, explain the behavior of alpha, beta, and gamma rays. Okay. Now, first of all, I will speak about alpha, beta, gamma rays normally. Then today we have to go for the exam. Now 8:04 p.m. Right? 8:04 p.m. So you have exam for 20 minutes. 20 minutes exam. 20 minutes actually 15 minutes exam. 15 minutes you should be able to finish this. Make it I have named this as quick fire exam. Within 15 minutes you have to answer this. Right? Then online students I will send it through WhatsApp. WhatsApp taking I will put that. Physical students you have to write here and you have to hand over your paper. Okay, you have to hand over your paper. Then we will check on it. We will correct and we will give you in the next class. We'll see how much you're getting for this. Quick kick. Whatever we have done up to cathode rays. Okay, cathode rays and up to cathode rays. Whatever before canal rays, everything will come. Okay, can remember? No? Right. So you have to do the exam. Okay, now we'll speak. Explain the behavior of alpha, beta, and gamma rays. Right. Now, Buddha, I said there are three types of radioactive emission in radioactive substance. Who found this? Rutherford. Rutherford told there are three types of radiations goes through this. So we'll say normally radioactive substance are kept inside lead. Normally radioactive substance are kept inside lead to avoid this radioactivity goes out. So they just store this inside the thing like this. Lead. They will store this radioactive substance. They will store like this. In this radioactive substance, there are three types of emissions. Right? There are three types of emission in this radioactive substance. Those are namely alpha, beta, gamma. Okay, those are namely alpha, beta, gamma. Right? Alpha, beta, gamma. So we'll say this is the radioactive substance. We think like this. This is the radioactive substance scale. From this radioactive substance, there are three types of emission called alpha, beta, and gamma. There are three types of emission. There are three types of emission. Moqadde alpha, beta, gamma. Who told this first? Rutherford. So normally this is lead. This is lead. PB. Lead. Normally they keep lead. Normally in Sinhala they call EM here. EM. EM means they used to bout. You know, bouting. Are in circuits and all are green color board they are dot here. That is from lead. We are calling EM. Right? Then you can write like this. For what I have asked. What's the question? Behavior of alpha, beta, gamma. First of all, we'll write this. Next week, we'll speak about the entire behavior. Then we'll write like this. Radioactive substance releases three types of radiation. Radioactive substance releases three types of radiation. Within bracket, right? In brackets, Rutherford, because this was said by Rutherford. Right? Now listen. And this alpha and beta, this alpha and beta, normally for alpha, we write 4, 2 here. For beta, we write 0, -1. For gamma, we don't write it. Because alpha and beta, we are considering as particles. Right? Gamma, we are considering as an energy. Right? That's why we don't write numbers. Normally, what is the mass number? This is this one, atomic number. Okay. Normally, actually, alpha kela we are talking helium nucleus. What is alpha mean? Helium's nucleus. What is helium? Helium also, Buddha, you write like this. Helium, you write like 4, 2. Alpha mean it doesn't have electron. The atomic number what make electrons. Alpha, no electrons. Remember this. Alpha has no electrons. Helium has electron. But helium's nucleus has no electron. Therefore, for this alpha, because helium's nucleus when you take, this is equal to helium's nucleus. Because when you take helium atom has only 2 electrons. Helium atom has only 2 electrons, right? So helium nucleus mean made out of 2 protons and 2 neutrons, right? Therefore, we are calling alpha as helium nucleus. Helium nucleus or helium 2 plus. We can call helium nucleus or helium 2 plus here. Is it clear? Right, like this. You just keep some space to draw this. We'll write like this. Okay. Alpha and beta are particles. Alpha and beta are particles. Right? Alpha and beta are particles. And gamma is an energy. And gamma is an energy. Alpha and beta are particles and gamma is an energy. It can be represent as below. It can be represented as below. Here, keep some space to write those alpha, beta, gammas with number. Then write the next point. Alpha is also known as alpha is also known as like this. Alpha is also known as helium nucleus. Helium nucleus. Alpha is also known as helium nucleus. Within brackets, you can write helium 2 plus. Can you understand පුතා මේ මොකක්ද කියන්නේ කියන එක? ඔළුවට යනවා නේද? හරියට take this to a head and do the work. හරි. Then අගල ඉතුරු ටික දාලා. Okay. ඉක්මනට අඳින්න. After that, you have to write the exam. Online කට්ටිය, I will share the paper. එන්න මේක තමයි paper එක ඕගොල්ලන්ට කරන්න ඕන paper එක පුතා. එන්න මේ paper එක තමයි ඕගොල්ලන්ට දැන් කරන්න ඕනේ. Right. So you can zoom this, you can check this out. මේ paper එකම I will send in WhatsApp. හරිද? WhatsApp එකේ මේක දාන්න. හරි මේක කරලා මේකේ PDF එකක් පුතා you send to this number, the number which I have sent the PDF ඒකටම ඕකේ write the answers and make it as a PDF and upload the answer. Now online physical කට්ටියත් ready වෙන්න exam එක ලියන්න. Each row sit one by one. You'll get 15 minutes to write this paper. 15 minutes වලින් මේ ටික read කරලා answer කරලා ගන්න. හරිද? ඕනනම් 20 minutes වෙනකන් I can give you the time. In 20 minutes try to finish it. කරලා yes. හරි. එච්චරයි එහෙනම් අදට. Then we'll meet the next class.